in this video, we'll be talking about writing reflections of functions. So we have two different reflections that can happen for our functions. The first is a reflection in the x-axis, and that is when the graph of y equals negative f of x is a reflection in the x-axis of y equals f of x. So we are multiplying the output by -1 changes their signs. And so we see an example here. My black line is my parent function, and not a parent function, but just the function given. And y equals negative f of x is a reflection in the x-axis. So that just means that we are flipping my black line here across my x-axis, which is that horizontal line. And then a reflection in the y-axis is the graph of y equals f of negative x is a reflection in the y-axis of the graph y equals f of x. So here we are multiplying the inputs by -1. And so we see here that my black line here is just reflected across my y-axis to get my blue line. So reflection in the x-axis, we are multiplying the output by -1. A reflection in the y-axis, we're multiplying the input by -1. So let's look at some examples of writing reflections of functions. So at first we have that f of x is equal to the absolute value of x plus 3 plus 1, and I want to do a reflection in the x-axis. So reflection in the x-axis I see up here, that means I am multiplying my output by -1. So my g of x is going to equal negative f of x. So here f of x is the absolute value of x plus 3 plus 1. So I'm going to do the negative of that whole thing. And so that means I'm really distributing this negative to my absolute value and to my -1. So that means that g of x is equal to the negative absolute value of x plus 3 minus 1. And we can go ahead and check this with Desmos. So going over here, I can type in my f first. So I have x plus 3 plus 1. And then when I do my reflection, I have negative absolute value of x plus 3 minus 1. And so looking at that graph, I do see that that is reflecting across the x-axis. Okay, now we're going to look at that same function, but we're going to do a reflection now in the y-axis. And so when I'm doing reflection in the y-axis, that means I'm multiplying the inputs by -1. So that means that g of x is going to equal to f of negative x. And so when I do f of negative x, that means I'm replacing x in my function with negative x. So this is going to be the absolute value of negative x plus 3 plus 1. And then I can do some operations here so that my x will again be positive. And so to do that, I'm going to undistribute a negative in my absolute value. And so what that means is I'm going to take out a -1, or in other words, just negative. And when I do that, my x becomes positive. And if I take out a negative from +3, this is going to become -3. And I can check my work. I see if I redistribute that negative, I get back to where I started. I get negative x plus 3. And so the reason why I'm doing this is that now I can rewrite this absolute value to be -1 times the absolute value of x minus 3 plus 1. So I am just breaking apart the absolute value. And now when I do the absolute value of -1, I get +1. We learned about that. And so I get that g of x is equal to the absolute value of x minus 3 plus 1. And then I can go ahead and check that on Desmos again. So I have my same f function here, but now that's going to become x minus 3, and this is going to be x plus 1. And so I see, looking at that, that is definitely reflected across the y-axis. Okay, now let's look at one last one. So here I have f of x is equal to 1/2 x plus 1, and I want to do a reflection in the y-axis. So since I'm reflecting the y-axis, I again want to multiply my inputs by -1. So I have g of x is equal to f of -x. So that means I am replacing my x here with -x. And so when I do that, -x times 1/2, I just get that g of x is equal to -1/2 x plus 1.